There are going to be times when we may want to apply some type of function to every row in our data frame or every row in a specific column or series. To do this, we can use the apply method. It can be used to clean up the data formats or create a new value like normalizing points across season. The first parameter the apply method expects is some type of custom function we define. It then passes every value in the series to the function and returns a new series object, which we can either save to the previous column name or store in a new column name. Let's look at an example of adding a year to each of our player ages. So if we read in our player stats total CSV, we can get a sample and see that we have an age column. Let's say we wanted to add a year to each of our players' age. We can create an add year function that takes the current age and adds 1, and then let's apply that to the age column of our data frame. So first we need to define a function add year that takes the current age as an input, and what it's going to do is take that current age and add 1, and then we'll save this as the new age, and from there we will return the new age. So let's define that, and again if we look at our df info, we'll see that our age is a float object, which should allow us to add 1 to it. Now to run the apply method, we will take our age column, apply, and again it's expecting that function that we defined previously. So if we run this and we got an error, and that's just because I spelled current age wrong. And so let's run it again. And here you'll see each row we went and added 1 to it, and it was returned as a series. We can also use the apply method on multiple columns within a row. So let's say we have the total games played and total points scored as 2 columns for some NBA players, and we wanted to apply a function to calculate the points per game. Pandas is going to pass the row values to the apply method if we call it in a unique way. When it does this, it will pass them in a list, which means it will use index positioning. So if we know which position our total games played and total points scored are, we can use it in this function. So first, let's define a new data frame with some player stats for some various players: LeBron, Dirk, Wade, Curry, and George. We have their total points and their games played. So let's turn this into a function. And again, just look at the head. And there we have it. And so what we want to do is actually get the points per game, which will take a row as an input. So we see that the games played is in the 0, 1, 2, 3rd position, and the total points is in the 0, 1, 2nd position. Let's define a function and store these in the variable. So we'll call this one the PBG calculator, and this time it's going to take a row as an input. So our games played is going to be, again, our 0, 1, 2, 3rd row, and our points is going to be our 0, 1, 2nd row, and that means points per game equals points divided by games played. We want to return the points per game. So now we can define that. So it's going to assign the value to a variable based on the index position. We then pass these into the operator and return the points per game. Then we will want to apply this to every row in our data frame. The first parameter will stay the same in our apply method, but this time we also pass in an axes parameter. So if we take our data frame and apply, we want to send in the points per game calculator. But this time, we're also going to pass in the axis parameter to tell it to loop over the columns. We do this with the 1, which is for columns, rather than the 0, which is the default for the rows. So now if we ran this, we would have our points per game calculations for each of the rows. So you see it returns a series just like the age we saw before, but we can save this into a new column by naming it the points per game, and then running that same apply method, but this time we're saving it as a new column. So if we look at that same data frame, we have the new column with points per game, which was taking the total points divided by the games played. Let's look at another example, but using column names rather than positions. We can create a free throw percentage calculator and apply it to our data frame. Let's go back up to our original data frame and copy this, and we're going to run it again to override the previous data frame we just created. Here we're going to define a variable, define calculator, and it's again going to take the row as the input. However, this time instead of using the index position, we're going to call it directly the column name of rows free throw made divided by rows free throws attempted, and all of this is going to equal the free throw percentage, at which point we will return the rounded free throw percentage to one variable. And one last thing to call out here is if we're dividing by 0, we're going to run into some issues. So let's just add a very small number just in case. And now again, we can run our apply method, which takes our free throw, just to make sure we're spelling it correctly, as the first input. And we're saying loop over the columns. And let's save this as the free throw percentage. And now if we look at a sample, we see that our free throw percentage, we got some 80% and Dirk even a 90% shooter. You'll notice we applied the free throw percentage calculator for each individual season. But what if we wanted a player's career free throw percentage? We would need to group by the player ID or the player name and then sum the columns and apply our function. So again, to do this was getting the free throw percentage for a particular year. But if we wanted a career, we could say df group by. Let's group by the player name. Let's sum their statistics, and then let's apply our free throw calculator. Again, saying the axis equals 1. And here we're just going to save this as a final. And then let's sort the values in descending order. And so it looks like we have a couple people that were shooting a career 100%, most likely because they only took very few free throws. But then we have some of our all-time great free throw shooters: Curry, Nowitzki, Novak, Bogdanovich. Didn't realize he was so up there. And then some of our all-time worst free throw shooters. And again, you just look for DeAndre Jordan. Doesn't look like he is in that bottom. Oh, there he is, DeAndre Jordan, at a career 40% free throw shooter. And again, we rounded the variable. For free throws, we might not want to round it to 1, which means we could go here and run it again with 2. And there we go. This gives us a little bit better look.